Harvey, Hannah.
All right, section 6.1, new chapter, polynomials. So the whole chapter is going to be focusing on polynomials and what we can do with them, and what their graphs look like, and how we can factor and simplify, and all this fun, making life easier as a mathematician is then like making life more efficient. Okay, so but first, what is a polynomial?
Something.
It's pretty important to know what we're talking about, right?
One.
Well, maybe we should start with what's a monomial. Do you remember that one?
One.
What?
Something one.
One, something one. A monomial is an expression that has, it's like a real number or a variable or the product of a real number. So I'm going to write that one down real quick. Monomial. We've talked about these before. It's a real number, a variable, or a product
Need what?
of a real number and a variable. So then a polynomial, do you know what poly means?
Two.
Or more?
More.
Two means by, like by would be two. Bicycle?
Yeah.
Right.
Probably.
So poly is many. So it can be the sum or difference of many monomials. It can be actually a monomial. A monomial. Or the sum or difference of monomials. I think it'll make a whole lot more sense when we write some of these. So I'm going to scooch this up a little bit, okay?
Is P of X just Y?
Yeah.
Why do they do that?
I don't know. Okay, so if we have the function P of X equals, I'm going to try to space this out. Yeah, A, X.
But you're not doing the two.
I am. I'm going to change my colors here. So this is the first, not two, sorry, it's an N. The first term of this is going to have the nth degree. Added to that, I would have the second one, you're going downward, would be the n minus 1 then, times x to the n minus 1. You'll see it a little bit more clearly when we use actual numbers also. And I could say plus a sub n minus 2 times x to the n minus 2. And it could keep going, right? This could keep going all the way down to where you have a sub 0. Like that's your constant term. This would be where n is non-negative integer. N is a non...
What are the three dots in between?
It keeps going, like that's the pattern. They're called ellipsis. It just keeps going. Non-negative... non-negative integer and coefficients a sub n and coefficients a sub n down to a sub 0 are real numbers.
So what is this?
This looks super complex for something as simple as, let's just say if p of x equals 2x to the third minus 5x to the second minus 2x plus 5. I'm spreading it out for a reason. I'm going to start labeling some of this stuff. So do you notice, I'm going to use the highlighter to point this out, then I'm going to get rid of it all. The power, the highest power is first. Then it goes down, and no power, right? Do you see that?
Mm-hmm.
So that's the grammar side of it. Like we write it in descending order. The first part, let me get rid of all those highlight type things. I'm gonna leave them there. The first part, this thing, is called the leading coefficient. we've used leading coefficients before, like when we were completing the square, you couldn't have a leading coefficient other than 1. We would divide it out. This whole thing together is called the cubic term. Oops. Then we have, what kind of term here do you think this would be called?
Not cubic,
No.
but squared.
Which is what?
Quadratic.
Yep, quadratic. That's the quadratic term. And then what about the, I'm including the negative part of it. I should have done that here too. This includes the sign there to it. The whole thing. So the tan one that I've highlighted, what kind of term is that?
Which one?
The negative 2x. If I were to just
Linear?
graph. Yep, linear. And then the last one?
Term. No.
It's what, Lily? Constant. The whole thing together.
They're just making up an equation here, right? Like
Yeah. The whole thing together is called a polynomial. It's made up of individual monomials. There's a monomial, there's a monomial, there's one, and there's one, right? Okay? We can talk about the degree of a degree of a polynomial. The degree of a polynomial is based on the largest degree or power of any term in there. There's the degree. We can define the degree of the polynomial. If you want me to write it out, I can. You want me to write it out?
Write out what
Probably
now?
should. The degree of a polynomial. The degree of the polynomial is the largest degree of any term of the polynomial. The largest degree of any term in of the polynomial. And that's how we name them then. I think we've talked about these a little bit before at least. It's up to you if you want to write these with me or just kind of as a quick exercise of telling me what they are. If I have my polynomial example, I'm going to give you several, and I'm going to keep changing colors so we can stay consistent with it. So if I have something like 6, how many terms are there?
And 6.
0.
1.
There's one term.
Oh, term in it. I'm like,
You
to the power.
name using the number of terms. So name based.
Are you supposed to write these all down?
No. On number of terms. And then we can also stick in here degree name using degree. And what is the degree?
What?
Of 6. What's the degree of 6?
0.
Exactly. There's no powers. So you would call this a constant. When the degree is 0, you call it a constant. Here's an example. There's one term. It's a monomial. Bless you. If I stick this next one in here of x minus, plus 3 will do. What's the degree?
Well, you have an x to the 1, so 1.
Right. So what kind of naming is it? Is it a constant? Is it we
To
took
graph it, it's
it,
linear.
of these? Right. Yeah, it's linear. Number of terms? Number of terms?
2.
2. Name it based on number of terms. And there's 2 things.
Binomial.
Right. You don't have to write these. You can just follow along. The next one. How about this one? 3x squared. What's the degree?
2 of them.
It's
2 degrees.
The degree is 2. Name it using the degree. Is it a linear? Is it a constant? Is it a cubic? Is it a with a power of 2.
Quadratic.
Quadratic.
I thought it was a power of 3.
How many terms are there?
2? 1. It's 1 because it's
1.
not a
There's
plus.
right, there's no plus or
I
minus.
thought it was like a times for some reason, like
There's
3
1.
times 6.
So it's a
Mono?
monomial.
Monomial again.
Okay, change colors again. How about this one? 2x to the third minus 5x squared minus 2x. What's the degree?
3. Do you do the highest one?
You do the highest one. What's it called based on the degree then?
Touches it 3 times cubic.
Okay.
And
How
then
many
3.
terms? 3 terms.
Trinomial?
Yep. Anything beyond try, it doesn't have a special name.
Is it just the
So
poly?
yeah, you would just say polynomial. So if I jump and do the last one here, if I have negative 2x to the fifth plus 3x squared minus x plus 4, what's the degree, the highest degree?
5.
5. Do you know what you call that?
I looked at it,
Quadrad.
Quintic. I skipped quartic. I'll put that in there again just because you have it quintic. Quintic, like quintuplets. And then how many terms?
5. 1.
1, 2, 3, 4.
4.
Okay, so we just call it polynomial.
Oh.
Your book says polynomial of 4 terms. I've never heard that generally used. I've heard polynomial, never beyond that. Last one that I just want to make sure you know the name. If it's a 4th degree, we call it a quartic. So something like x to the 4th plus 3x to the 3rd. And that would be 2 terms binomial. Okay? So, using this idea, you have it in your book if you need to take a look, because I'm going to scroll up to do example 1. Write each polynomial in standard form. Write in standard form, then name it, right? Okay, so part A. Something like negative 7x plus 5x to the 4th. What's the correct way to write this?
Well,
The highest ones first.
Okay, so how would I rearrange this?
5x to the 4th minus 7x.
Cool. So how many terms are there?
2.
So we call it a
Binomial. There you go.
in what degree is it?
To the 4th.
So we call
It's
it
a polynomial.
based on the degree. It's right here. If you can read my writing.
Quadratic.
Oh, that part of it.
Quartic.
Quartic.
Quartic binomial. I'm going to change colors for the fun of it for part B. This one is x squared minus 4x plus 3x to the 3rd plus 2x. Let's write it into standard form first.
Okay, so you're going to have 3x to the 3rd.
And that stays positive. Keep going.
Then you're going to have x squared plus it.
Mm-hmm.
And then you can combine the negative 4 and 2.
Yeah.
Negative 2x.
Okay. So we've taken care of all of them. Good. It's in standard form. What's the degree? How do we classify it by degree?
3.
So we call it a
Cubic.
cubic. And by the number of terms.
1, 2, 3. Trinomial?
Yep. Cubic trinomial. Generally, when we're naming them, we say classify by degree first, then by the number of terms. So it'd be a quadratic binomial, quadratic whatever, cubic trinomial, cubic binomial, cubic monomial. Okay? All right, let's keep moving. Example 2. Using a graphing calculator, we're going to determine whether the linear model is quadratic, cubic, or linear. So here's our x and y. We're going to put them into the table. 0, 5, 10, 15, and 20, and the corresponding y's. 10.1, 2.8, 8.1, 16.0, 17.8. So I'm gonna do a little video on how we put these in here because sometimes it's quite helpful to know how to use a calculator. Can I have a calculator?
Anyways.
May I? Thank you. Turn the light off. Oh, it's still there. That's really bad. You move it where you need to move it.
It's like, I don't know.
Is it better when wait. Is it better now that the screen's on?
Is this how you?
Yeah, it's better. Okay. Okay, so on your computer, your calculator, you're gonna go to list right here. So second list. And then in here, we're gonna go to, actually no, I take it back. You're gonna go to stat, right there, stat. And you're gonna go to edit. And I wanna clear anything that's in there. So I'm gonna go up to that L whatever and press clear and, clear and enter. And I can go over there and press clear and enter. And, okay, so L1, I'm gonna enter the 0 and enter 5, 10, 15, 20, right?
Mhm.
And then we had corresponding numbers, and I'm noticing here in this particular one, I've got L1 and L4. If yours is L2, that's fine. Just recognize what it's listed as.
Where did L2 go?
I don't know. Sometimes it just does that, and I don't know how to reset it. It doesn't matter as long as you take note of it. 10.1.
2.8, 8.1, 16.0, 17.8.
Okay, those all look right?
Yeah.
Okay, so then we're gonna go to do a linear model, a quadratic model, and a cubic model to see which one best fits these data points, right? So we're gonna go to linear regression under stat and under calculate. So there's your linear regression. I just want to point them out to you. There's linear regression.
That's under what? Stat?
Stat. So if I go to my stat button, and then I need to arrow over so that I'm under calc.
Mm-hmm.
And I'm going to arrow down. So there's your linear regression. There's your, let's see, where is it? Quadratic regression right there, and then cubic regression,
So
all
you
of
just
them.
graph that?
So I'm going to do 1, and it says L1, but remember mine had L4, so I need to go down here and change that. And those are right here above your different numbers. You see that? So I'm going to say second L4, and then press enter and enter and enter until you finally get your, so there's your A and there's your B for the equation. You need to write that down somewhere so that you can type that into your y equals mx plus b. So let me write these down real quick.
Here.
Yeah.
Then what do you do?
0.572 and then 5.24. So if I go to, hold on, what? Press enter a whole bunch of times. Y equals, and I'm going to clear. I'm just going to ignore all the other ones. I got to turn off all the other ones. I got to clear them all from earlier. Okay, so if I go back up to the top one, and I put in 0.572x, ooh, wrong thing. 0.572x plus 5.24, and I go and graph, and I need to turn in plot 1, if it will. Oh gosh, how do I do plot? Here we go. Here we go. I gotta change it to L4 here too, so that we can see this. Okay, so now I'm gonna go to graph.
Window.
Oh my gosh, my window is an issue again. Okay, so we're looking at 0 to 20. So I'm gonna go to zoom, window, not there, window. And I don't really care how far I go that way, but I want to go up to maybe 25 so I can see the whole thing. Go by 5, so it doesn't matter so much. Y minimum, -2, I don't care, and then up to 20. Now we'll go to graph. There's all of our dots. How well does that line fit those dots?
Not very.
Not very well at all.
It's got a like curve.
Right, so I'm going to get out of here, And I'm going to go back to the stat and the calc. And I'm going to try the quadratic.
Wouldn't you be able to tell it's crossing how many times?
Kind of,
But
yeah.
you kinda know it's
You can see, so if I go back
quadratic
to that
based on
graph,
where
you're
those
right. Do you see this, like the pattern of these? It doesn't look like much that we've ever done, right?
Mm-hmm.
So, but I want you to get the idea of how you do this. So I'm going to go back to second home screen, and I'm going to go back to stat, and I'm going to go back to calc, and I'm going to do the quadratic one, just so you get the practice of doing it. L1, L4, right, press enter until you get the A, B, and C. There's your A, B, and C for your quadratic equation. So 0.0594 is okay. Negative 0.616 and 8.211. So if I go back to y equals, and I clear that, and I type that in. 0.0594 x squared minus 0.616 x plus 8.211, and I go to graph. Well, if it's a little better, right? You see that?
Mm-hmm.
But it still doesn't fit it great. So that's not so wonderful. So let's get out of here and go back to stat calc, and we're going to go down to the cubic, and then still it's L1 and L4. Press enter a whole bunch of times until you get down to say, do your work calculator, and you're going to want to write down the A, the B, and the C, and the D. So it's negative 0.012466, 0.4334, negative 3.296, 10.081. Good enough. Y equals. Clear that. Negative 0.012466 x to the third, and then plus 0.4334 x squared minus 3.296 x plus 10.081. Graph. Look at this.
Wow.
Oh my goodness, it's hitting like all of the data points. What do you know? Gee, which one matches the data best?
Maybe the cubic.
Yeah, the cubic model appears to be the best fit. So that would be your equation of, there it is. It's kind of ugly, but it's there. So you have some idea of how to do all this. I showed it on the calculator. Okay? I would highly recommend you bookmark this video because that's a very useful tool when you're doing any kind of data stuff things and entering it into your list. Okay, thanks. Here you go. I can send that video to you if you guys need it.
Yes.
Thank you for videoing it, Hannah. Here's your notebook. Okay, so we had something, just quick review. You had some data points in here like this. And we had a line that looked like that. That wasn't so great. So we had one that same. So I'm not going to redo that. Let me just get rid of this. So then we had a new graph when we did the quadratic model that looked kind of like this. And it was better, but it wasn't great. Then we had a better one even still that went kind of like this and hit all the data points. That was the cubic one, right?
Mm-hmm.
And there was an equation. Do you guys have the equation written down? No?
No.
I don't either.
Numbers.
What's that?
Did you write it down here now?
Yeah, okay. So you can use that equation, though, that your calculator spit out for you to predict anything that might actually be on that graph then. You would plug it in for your x value, and you'd use your table for that.
I wrote them all down like we could write it out.
Yeah,
but-
well, here, tell it to me real quick. It was y equals what? Point?
Wait, I have A.
Yeah,
B, C, and
yeah,
D.
that's right.
A
Negative
equals negative 0.01246.
x to the third plus 0.4
334. I wanna
x to
write
the
these
second.
down.
And then it was
Negative 3.296.
right minus 3.296x and
10.081.
plus 10.081. So that would be your equation. And if it said predict what it would be when x equals 2, you would use your calculator and your table and plug in 2 there, 2 there, 2 there, right? Not something I really want to type in. That's why we have the calculator. Okay. There's one more. You guys, I'm going to have you do it on the calculators. So go back to your tables.
Let me get my calculator.
Go to the tables, so you go into stat and edit and your lists. So we have the year and we have production of troy ounces of gold. So year was 1975, 1980, we're going by fives, 1985. 1990, 1995,
I think mine's
2000.
dead.
Uh-oh.
I know mine's about
It's a weird charger.
Do it with somebody. 38.5 troy ounces, 39.2, 49.3, 70.2, 71.8, 82.6. You have those in the list yet?
I don't know what I'm doing.
Right here.
Confused. Oh, it's just
Arrow up to this. You know one. What are you
So you
in?
go to second
No,
list.
you're in-
Did you go
no,
to
no.
list or stat?
Stat. Edit.
Delete everything you have in it.
Yep. The arrow all the way up to the very top where you're highlighted L1 or L2 or
And
3.
just clear it.
Clear and enter.
L1.
Press clear and then press enter. And then type in 1975, 1980,
Oh, okay.
1985.
What is this tracking? What is it?
The it says
Years.
the table below shows the world gold production for several years. Find a quartic, so we're going to be using the quartic regression thing, function to model the data. Use it to estimate the production in 1988.
You want to read the production thing?
Oh, you know what they did though? I want to point out real quick. They didn't use the actual numbers of 1975, 1980. They used enter the data, let 0 represent this one here of 1975, right? So instead of entering 1975 in your calculator for the list one, I'm going to change colors here. I want you to enter 0,
Wait, what?
0 for 1975, and then 5, 10, 15, 20, 25.
That kind of makes sense.
It does make sense, right? You have to have a starting point.
Mm-hmm.
And you don't necessarily want to use years because it makes the equations wonky. You have to use a starting place.
It's like that.
Yep. And then you made to list off the numbers for L2
Yeah, I have that.
or for
So then do you
UL4.
put it into the quadratic
Quartic.
quartic, I mean.
Quartic regression. It's telling us find a quartic function. So, Annalise, you getting it or you want me to read them to
I
you?
got it.
Okay.
So once you get this,
Yep. So then go to your stat plot, which is second y equals.
Do I go there too?
Yeah,
or-
just make sure you can so that you see. Go second
I
y
leave it?
equals. And make what?
what do I do with this?
Second y equals. Okay. Stat plot 1. You want it on, and it should be L1 and whatever 2 you used for the x and the y.
Oh, I can't.
Yours is good. Press enter. You're good on that. L1
Okay.
L2. You're fine.
How do you turn it on?
Press enter. Go over here and press enter.
Ooh, that's
You're on the
fancy.
on. Press enter. You're good. Okay. Now do the quartic regression. So go on your home screen. Go to stat and calc.
Okay.
Stat.
Then we're gonna go arrow down several times. How many times to quartic regression? I think it's number 7.
No, that's a quartic regression. So I
Okay, so press enter. Yep.
Anything I have to do here?
Then you've got the L1. You got the x and the y in there correctly. Just keep pressing enter until your calculator starts working.
So it gave me numbers.
Mm-hmm.
So I have to write these down now.
So it gave you A, B, C, D, E, right?
Yeah.
Okay, so what was A?
9.03,
B?
0.052,
C?
0.96,
C, D?
negative 3.9,
And then E?
38.9.
Okay, so all of these are
I'm
representing...
rounding. Is that fine?
That's fine. These are all representing the coefficients of your quartic, which is to the 4th power, equation. So this would be your x to the fourth, x to the third, x to the second, x, and then no x, right? You see how I just added those all on there? This part your calculator's not giving you. So when you write it all into an equation for your y equals, and you type it in there to see how your graph compares to your plot, you would write
So what do
in,
you write
in the y equals, you'd write in 9.03 x to the third, and make sure that you arrow
9.03.
x to the third when you, sorry, to the fourth. When you put to the fourth there, you need to make sure that you arrow over so that you get out of the power section of when you're typing it in. And then say plus, since the b was positive, 0.052 x to the
Wait,
third.
0.0 what?
52.
So I do this in my y plot then.
Yep,
Okay.
y equals. Clear that one that's there. Yep.
Plus.
Plus 0.96 x squared minus 3.9x plus 38.9.
Minus 3 point what?
3.9x.
Oh wait, how do I delete this? 9x. Take away or plus?
Where were
Take
you?
away
The last
3.9.
Take away 3.9x
Uh-huh.
plus 38.9. And as long as we copied everything down right and wrote it right, we should end up with something that looks kind of like, I'm not going to have my
Can you
scale on
graph
here.
this then?
Yeah, press graph. You should have something that looks like a stat plot like this.
Well, why might I want to do this?
Your window. Look at the
No.
numbers you're using. Let's check your y equals. Yeah, it's just your window. Your window's not showing enough. Look at the numbers we're using. We don't need to go all the way down to negative 20. Up to 25 will do, so we can see a little bit past where we are. The y minimum, we don't need to see below the x-axis because of the numbers we're talking about. But you're going, the lowest number on the production of millions here is 38. So maybe we'll go down on the y minimum to 30, just 30. And then we'll go up to, so the highest one was the 82. We'll go up to 90 for the y max. And then, oh gosh, what is your y equals doing? Oh, you typed that. No, that's what you told me to type. Oh, this was negative, Lily. That was important.
What?
That when you read them off to me, the b was negative.
Oh.
Oops. Liliana test. Oops.
It's still not. I don't know what it's doing. I'll have to mess around with yours. Did yours do it?
Window.
Oh, window. Well, you got to learn how to do this. So we use these. The smallest
That's
x value.
example 2. So example 3.
Okay, still same thing. The smallest x was 0.
Yep.
The biggest x, press enter. 25 is fine. X scale is
Okay.
fine. The minimum for y, we don't need to go down to negative 2. We were looking at like the lowest value
Lowest value
was
like
the 38. So go down to 30 for y minimum.
30.
The y maximum, the biggest number was 82. You got to go beyond that. Go up to like
Right.
90
Yeah.
and then press y graph. I don't know what it's doing. We probably chopped off too many numbers of yeah, we did. We'll mess around with this. All right. Thanks for joining us.